Hello, everyone. Today we're talking about scientific notation. So scientific notation is a times 10 to the n, where a is greater than or equal to 1 and less than 10, and n is an integer. Now keep in mind that a is one digit in front of the decimal. That's what it means by between 1 and 10. So I need to write these in scientific notation. So my decimal is currently at the end. So I need to move it in between the 1 and the 9. So in that process, I'm counting places, not zeros. So I'm going to move it 3, 6. So this is 1.9 times 10 to the 6th. Here, my decimal is between these two zeros. I need to move it so that I have one digit in front. That would be the 7. So that's 7.04 times 10 to the negative 4. And the negative exponent means that it's a small number or that I moved right. Positive exponent means that it's a large number and I moved it left. If I make the number smaller, my exponent gets bigger. If I make the number bigger, my exponent gets smaller. So I want you to pause and answer 3 and 4. Okay, so number 3 is 5.004 times 10 to the 10th, and 4 is 6.61 times 10 to the negative 8th. Now I need to express my answers in standard form. So standard form is how you would normally write it. So here I have 5.3, so I need to move the decimal 7 places to the right. So that's 5.3. There I moved it 1 place. So for the remaining places, I add zeros. And I know that that means 6 zeros because I went 1 of the 3, that's 7. Now here it's negative 4, so that means I'm making a smaller number. So I need to move it 4 places left. So that gives me 0, 0, 0, 1, 0, 9. And so please pause and try number 7 and 8. So number 7 is 9,130, and number 8 is 0.00007902. Now we're going to evaluate in scientific notation. So scientific notation makes it easier for us. So what we can do is we're going to rearrange this, and we're going to multiply 4.8 by 6 and multiply 10 to the 4th by 10 to the 6th by using our exponent rules. So 10 to the 4th times 10 to the 6th is 10 to the 10th, and 4.8 times 6 is 28.8. Now that answer is not in scientific notation, so we need to move the decimal place 1 more to the left. So we're making the number smaller. So when I make the number smaller, I need to make the exponent bigger by 1. So again, here I'm going to do 7.5 times 3.2 times 10 to the negative 5th times 10 to the 7th. On the tens, I use my exponent rules, so I keep the base and add the exponents. On my 7.5 times 3.2, and just multiply those on my calculator, I get 24 times 10 to the negative 2. I need to move my decimal over 1, so it's 2.4 times 10 to the negative 1, because I made my number larger, so I moved my decimal over 1 to the left. So I want you to pause and try 11 and 12, and then come back and we'll discuss 13 and 14. Okay, so here again, I multiplied my 2.06 times 5.5, got 11.33. Is my exponent rules on 10 to the 4th times 10 to the 9th, and I got 10 to the negative 5th. I need to move my decimal over 1 more, so it becomes 1.133 times 10 to the negative 4th. Now I have the calculator open because I want to show you your calculator will actually do this for you. You do still need to know how to do it, because sometimes the questions are going to be explain it. And while your calculator will give you the correct answer, it will not explain. So you can see that I'm typing it in exactly as it's written. Oops, except for I forgot my 2. So if you forget something in your calculator, you don't have to completely retype it. You can see I arrowed over, and then I'm going to do second delete, which is insert. And I can type the 2, and it put it in where I wanted it. And it gives me the answer this way. That E means times 10 to the negative 4th power. So again, 12, I did it like where I do 8.1 times 1.96. Use the exponent rules on my negative 6 and 11 and got 1.587. Again, I can type it exactly as it's written on my paper into my calculator, and my calculator will tell me the answer. But again, I could ask you a question where you need to explain the process. And look, sometimes my calculator doesn't give me my answer in scientific notation. So I have to be able to convert that to scientific notation. So when I convert that, oops, I went the wrong way. Here I made the number bigger or smaller, so I need to make the exponent larger. Should be times 10 to the 6th. Sorry about that mistake there. Okay, now for 13, I'm squaring it. So that means, since it's multiplication, that I can square each thing using my rules. So I'm going to do 7.2 squared times 10 to the negative 10th, because power to power you multiply. So on my calculator, I'm going to do 7.2 squared. And that's 51.84 times 10 to the negative 10th. I need to make my number have one decimal place. I need to make it between 1 and 10. So I made the number smaller, so I'm going to make the exponent bigger. Now again, on my calculator, I can do that. By just typing it. And you can see I have the same answer. So please pause and do number 14. Okay, so I squared 5.29. I got 27.9841. Squared 10 to the 6th, which is 10 to the 12th, because I keep the base and multiply. I then made it scientific notation, which is 2.79841 times 10 to the 13th. Now we're going to divide. So division, we do the same way as we did exponents. We're going to divide our numbers. So I'm going to divide 4.2 by 3, which is 1.4. And then on the exponents, I keep the base and subtract the exponents. So 5 minus negative 3 is 8. So again, on 16, I'm going to divide the 1.76 by 2.2. Which is 0.8 times 10 to the negative 6, because I keep the base and subtract. That is not scientific notation, so I move it over 1, 8.0. And since I made the numbers bigger, I need to make the exponent smaller. So it's 10 to the negative 7th. So I want you to pause and try 17 and 18. Okay, so 17 is 7.5 times 10 to the 4th. 18 is 6 times 10 to the negative 10th. So now we have a word problem to do, and that's it for today. So gravitation. Isaac Newton's theory of universal gravitation states that the equation F equals G m1 m2 over r2 can be used to calculate the amount of gravitational force in newtons between two masses m1 and m2 separated by a distance r. G is the constant equal to 6.67 times 10 to the negative 11th. The mass of Earth, M1, is equal to 5.97 times 10 to the 24th kilograms. Mass of the moon is 7.36 times 10 to the 22 kilograms. And the distance R between the two is 384 million. So express the distance R in scientific notation. So again, I want to move my decimal so that it's between the 3 and the 8. So that'd be 3.84 times 10 to the 8th. Now compute the gravitational amount force between Earth and Moon. So we're going to do F equals 6.67 times 10 to the negative 11th times Earth, which is 5.97 times 10 to the 24th times 3.84 times 10 to the 8th. Oops, sorry. That's not the mass of the moon. I used the wrong number. The moon is 5. The moon is right here, which is 7.36 times 10 to the 22nd. The distance R is 3.84 times 10 to the 8th. So I'm going to calculate that. And actually for this one, I'm just going to show you how I would use my calculator. Now on my calculator, when I'm doing division, it's important that I type it exactly as it's written and I use the fraction button. So I'm going to do parentheses 6.67 times 10 to the negative 11th times alpha y equals for my fraction. Then in my numerator, I have 5.97 times 10 to the 24th times 7.36 times 10 to the 22nd over 3.84. Oops, I should put this in parentheses. Second insert parentheses. 3.84 times 10 to the 8th. Enter. And so the force is 7.6321475 times 10 to the 8th, or 28th, sorry. And I can't see the whole question. Special answer in scientific notation. So there is my answer. If you have any questions on any of this, please let me know in class tomorrow.